All right, I won't make you guys listen to that whole thing again for posterity. Okay. So where are we now? So last night, we should have been able to strip the audio from the movie files using FFmpeg or other files. There are other things that do that. VLC can also strip audio files from the movie files. There are other programs that can do that. If you do that, as Will showed yesterday, it's good to find another to double check that you're getting the right alignment of your audio and video. But the newer files should be pretty good with that. And then starting to run code. We should have been able to run that step one of the PRH file. And so we'll come back to that. Let's just do a very quick poll. I just want to ask you if you were able to do the movie times files last night. Were you able to do movie times file last night? So we'll say your options are going to be yes, no, or no, but didn't try. Just so I get a sense of where people are last night and whether they had problems or whatever. Save. Oops. Sorry. Launch. Okay, so we're have this quick poll. See if you can answer this program last for me. Just so we can get a sense of how people are doing, and then we'll just share the results so we can kind of gauge where people are at. And it's obviously it's okay if you didn't get there, but it's good to see. So what I'm seeing is great. Okay, so share results. So so we had a bunch of people who were able to do it. A lot of people who had some kind of issue, and then some proportion who didn't get a chance to actually try it. But so we did get some people working on it. We'll start from there again. I'll kind of go over again like where we should be, and we'll give a chance to like talk to you. If you weren't able to do it, we'll hopefully be able to have some questions later about where you guys were. Yeah. Yes. Chad coming in. Yes, but I don't know if that was if I got it right. So we'll show you what it should have come out to as well. All right. Okay. So where are we today? So step one. So here's our general information. Here's what we tried to do yesterday, understand the data a little bit. Today, we're going to start talking about actually using the data and importing and calibrating the data to get to a right place. So we're going to actually go backwards a little bit. We started working with actual data from a deployment yesterday. We're going to take one step backwards today and actually go by, okay, so when you first get your tag, how would you actually calibrate that data and calibrate the tag to kind of get a sense of like, yes, here's the data that is in a reference frame and using units that I think are accurate and that I know everything works in my tag, and how can I actually run through some of those scripts. And so Will's going to kind of focus on that calibration aspect today. Then we're going to actually make a little edit to the syllabus where we're going to come back and we're going to look at some of the frame times in movies. So that'll answer this question of how do I know that I got the right answer, that I got what I'm supposed to get. So we'll kind of look at those a little bit. It's an activity we didn't get a chance to do yesterday, but we'll throw that in today. And then we'll start actually running through this main CATS PRH tool today a little bit later on. So it's worth reminding you as we start getting into this data sets and you just start examining the code a little bit that, data in tutorials kind of looks like this, and data sets in the wild kind of look like this, right? Like you have this idea that nothing is quite as easy as it looks. And so when you start to examine some of the code that we're writing and putting it out there, that main CATS PRH tool, okay, that looks pretty nice. It's like really well organized. And if you dig into some of the sub functions, you're going to find there's a lot of like commented out codes and just like it's a little bit wild. And part of that is because in the wild we get all these data sets that have just like you get one data set that has an error and you want your code to be able to work for that. Like, oh, the pressure sensor didn't work on that one deployment, or the XY, like the videos were offset on this file. So there's a lot of like what kind of looks like junk in the code in there, and it's a little like horrified for me to put that out into the world. But it's there, and if we're always open to like people making changes and making things more streamlined for your data set as well. And part of that is just to like try to deal with these different errors that crop up from people based on their own data set or their own MATLAB versions and stuff. So keep that in mind, and keep that in mind as everything we're kind of doing here has multiple things. So one of the first things we're going to do today is talk about some of that options and some of those variability in what your data is going to look like is kind of built into some of these scripts. So the first thing we're going to do today is a function called import cats data, which is one of the functions in the main kind of toolkit here. So in our here, just navigate to this folder real quickly. In our main cat so from your GitHub, right, you have this main cats MATLAB tools. This is the one we're going to be running the most, the main cats PRH tool. The other one Will's going to run today is this calibrate cats, which is going to work in an individual script here. And then the one we're going to start with today is this one called import cats data. The way we're going, yeah, go ahead, Will. Go ahead, Will.
We have a quick question. If somebody was to create the WAV files from FFmpeg last night, yep, do we have them somewhere or do we need them?
At this point, yeah, okay, good question. We can, so all of the files that you need, if you need them, are in that example data folder. They're going to be, we put in all the workshop files. So all you need to have at this point, if you weren't able to make the files last night, is in this workshop files. There's this audio data output, which has all of the wave and audio files, and the movie times file here. So so all the files are there, but we won't need those yet. We actually won't need those until later on today. So right now we're kind of going backwards to dealing with this very raw data set. So where do you have these CSV files? What do these files actually look like, and how do we deal with this? So even before we get to movies, we kind of did the movie times last night because it takes time to run. So we needed you guys to run that file if you wanted to be able to run that. Today we're going to do this import cats file, which starts with these CSV files, which is with kind of the workhorse data files of the cats environment. So you have all of these different columns of data. If you open up any of these CSV files, you have all these different columns of data that we want to integrate into a MATLAB environment. And one of the reasons you can see that there's in any given deployment, there's sometimes tends to hunt over 100 files of CSV files. And so those are hard to read kind of one at a time. So we want to both synchronize them all together, but also we decimate them a little bit, because the way that the cats works is that you'll notice here in these accelerometers, the accelerometer is sampled at 400 Hertz, and each one of these is a different value. But other sensors are sampled at a smaller value. So they're sampled at, for instance, the gyroscopes are sampled at 50 Hertz. So this one actually looks a little bit different. So there you get these repeated values as they're sampled in here. So maybe this one, the gyroscope is sampled at 100 Hertz. So you have 4 repeated values here, and then 4 repeated values here, and then 4 repeated values here, over and over and over again. You'll see that in the magnetometer, and you'll see that in the accelerometer, in the pressure sensor here, pressure sensor or depth sensor here. This one, this is all the data still at the top, right at the surface right now. So there's a lot of repeated values, but you can see these values repeated over and over again, and at 40 times sometimes, because that is the depth sensor is only sampled at 10 Hertz. So this is what we want to use this import cats data for, is to kind of bring this into a reasonable file. And we're going to have you guys do this with the calibration data here in a second, but I wanted to show you kind of what this looks like in the end. So I'm going to bring in a random data file here. This is the mat file that's going to come out of the import cats data here. I'm going to import that into my workspace here so you can kind of see what that looks like. Should load that up. And you get these 3 variables. This is the 3 things we're trying to create here. The data file is that same data that we were just looking at, but now it's in this MATLAB file, and it's decimated down to 50 Hertz. So it's less repeated. There's going to be less repeated values within there. These are MATLAB date numbers and date times in here. And some of this, again, this is a data structure. You're not going to have to work with raw data too much, but all of these things are good to have your head around a little bit, so that if you do run into errors, you can kind of say well, what is this trying to do? What is this You can just follow the wiki if you want and just kind of run cell by cell by cell and never really understand the data. Part of this workshop is to try to get you to understand a little bit about what's actually being created and why. So this is why we're doing this this way, and I'm kind of going through it. But if you don't understand exactly what all these columns mean right now, it's okay. You actually could, you would never have to open up this file necessarily if you don't want to. But part of it is we're trying to get you to understand where we're coming from here. So this is a data structure. And those of you guys in the MATLAB workshop last night, you looked at that, that data table format. So it has all of that same data kind of aligned in these different columns here. The A data and A time are the raw accelerometer data and raw time for the accelerometer at 400 hertz. And that's why those are bigger. There's more rows in this one. There's 8 times as many rows in the A data as there is in the data. Are we getting questions here? Yeah, great. So Taylor's asking, when you're downloading the data, do you cut at specific sizes for the CSVs? Yeah, I find that when there's an option in CATS to download your data into certain CSV files, and so we always try to set it off as kind of the minimum here. So these 228 megabyte files so that they're easier to deal with and import. If you just get one file, there is we talk about how to use those. There is like CSV splitters in here that you can download that are that we talk about in the wiki that you can use to download, to split up your one file into multiple files that have 100,000 rows or something, and then you can import this in a similar way and use import cast data in a similar way. So if you have any issues with just the one big like 10 gigabyte CSV file, we can talk about how to split that up. That's all good here. Okay, so this is what we're trying to create. This is what we're trying to do. In the wiki, we're going to have you guys kind of follow this wiki around a little bit today. In the tag wiki here, there's going to be, so in the wiki, in the GitHub in the wiki, there's this spot about importing CATS data. That's what we're going to be looking at for the first step here today. There is going to be there's information here about how, like what we just talked about essentially. And then the basic code you're going to run is this thing called data equals import CATS data. So we're going to give you guys a few minutes to actually try to do this here, but I wanted to highlight why you have this import CATS data versus import CATS data true and why you might run these either way. This gets to that idea of sometimes data in the wild is a little bit messy. And so the reason you might do that is, so in this data set here, I'm just going to graph here the data figure plot data dot pressure. And then I'm going to flip the y axis so we can see it in normal things. Direction, reverse. And so now this is my data set here. What the import CATS data does by default is it's set to cut off importing your data files when you see that the tag is just kind of floating in the water. Because like in general, your tag just like pops off the animal and then it's just sitting there and it can float for sometimes a long time before you're able to recover it. And so this kind of looks for that and says like, okay, well, let's cut that off. I don't need to import all that. Let's save some memory and save all the time because you're getting your data back and you want to look at it right away. And so we want to truncate that file down a little bit. But sometimes in the wild, you get animals that behave funny. And so this distance, so some of these resting times at the surface for this animal, this is a whale in the Antarctic, were over an hour of just sitting there at the surface and it looks like the tag's off the whale. And so sometimes in your data set, if that's a possibility where you might just have a data set that has an animal kind of like logging at the surface, that's not really like, that looks like the tag is off the animal and would fool the code, that's what this switch is for. So you could put this true in there that says, that basically says like, just import all my data. Don't try to like do anything fancy, just import it all no matter what. So there are situations where you might want to do that. And that's one of those like, okay, my data in the wild might look different than the data in the tutorial. For today's purposes, you can just run it just like this. So basically, we're gonna send you guys to breakout rooms for 5 minutes and we'll come back and hear Jeremy's introduction here. But basically your script is just gonna look like this. You're just gonna try to run import CATS data. And then it's gonna ask you to select a file. And the file that I want you to select is actually the one, the calibration file. We're gonna try to make, for Will's workshop today, we're going to use some calibration data. So what I want you to do is in the example data, in the CATS folder, in this calibrations folder, there is this bench test folder. If you keep navigating in there, you'll get raw data from this bench test that Will made earlier. So this is the one I want you to try to run import CATS data on and get this started. So during Jeremy's talk, you'll actually come back and you'll have the data file that comes from this. So you just basically select this first file and it'll start running and start importing that file. We'll send you into breakout rooms for just 5 minutes in case you guys want to talk about it. It's sometimes easier to talk. Well, it's sometimes easier to talk about it in breakout rooms. So we'll just send you to random breakout rooms for 5 minutes and we'll come back in 5 minutes. Hopefully it shouldn't take you long to just get this started. And you guys can ask each other questions and call me in if you have questions as well. So we'll send you into breakout rooms.
One quick note on the breakout rooms too.
Yep.
It doesn't seem like Zoom allows us to hold the breakout rooms from day to day. So unfortunately, it looks like everyone's going to be sort of, meeting new people again.
Yep. Sorry. Sorry about that. And eventually we'll start letting people just like choose your own rooms if that's useful for people. So then this file is asking me now as well for the text file that comes with the data. So I'm going to select that as well, which is just this file in that same folder as that tag 70 data. And that just is the metadata file for that folder. So I'm going to send you guys out to breakout rooms. We'll just spend about 5 or 7 minutes doing this today. And then we'll come back and we'll hear Jeremy give an introduction to kind of some Biologging stuff. Jerry, is that okay with timing wise for you?
Yeah, no worries.